Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0723, indicates an intermittent failure of the output shaft speed sensor, which is often a critical component in the automatic transmission system of the Honda CRV models from 2011 to 2016. This error code suggests that the sensor is not sending consistent signals to the powertrain control module, PCM, which can hinder efficient vehicle performance. The output shaft, also known as the countershaft, speed sensor plays a vital role in monitoring the rotational speed of the output shaft, enabling the PCM to make necessary adjustments for optimal shifting and fuel efficiency. Any malfunction in this sensor or its associated circuit can lead to performance issues, such as erratic shifting behavior. It is crucial to address this DTC promptly to ensure the proper functioning of the vehicle's transmission system, as failure to do so may lead to more severe mechanical issues down the line. Caution should be exercised, as this DTC is related specifically to an electrical problem rather than a mechanical one in the transmission system, necessitating precise electrical diagnostics. The output shaft speed sensor, often referred to as the counter shaft speed sensor, holds significant importance in the automatic transmission system of the Honda CRV. Located on the transmission assembly, this sensor helps determine the speed of the output shaft to provide data necessary for the PCM to optimize shifting patterns and engine performance. It operates by sending signals based on the rotational speed of the output shaft, allowing for accurate control of the transmission. In cases where the DTC P0723 is triggered, it indicates an intermittent failure in the functionality of this sensor. This failure is generally attributed to electrical circuit issues, such as loose connections or damaged wires, rather than mechanical problems within the transmission. Understanding the location and role of this sensor is crucial for accurate troubleshooting and repair. Several possible causes can trigger the DTC P0723 error code related to the output shaft speed sensor. One common cause is poor connections within the electrical circuit, which may prevent the sensor from transmitting accurate speed signals to the PCM. This can happen due to corrosion, dirt, or wear over time. But another likelihood is loose terminals that disrupt the electrical signal pathway. These loose connections can lead to intermittent failures, making it challenging to diagnose the problem at first glance. Open wires in the circuit, specifically in the wiring leading to the speed sensor, can also be responsible for the error code. Such breaks in continuity may lead to a lack of necessary voltage at the sensor, resulting in a DTC being set. Thorough examination of the wiring and connections is essential to identify the primary cause of this malfunction. When facing a DTC P0723, symptoms may manifest in various forms, particularly affecting the vehicle's transmission performance. Owners may notice erratic shifting patterns, which could include unexpected hard or soft shifts, delays in shifting, or the vehicle hesitating in gear changes. This can lead to a frustrating driving experience and may raise concerns regarding safe vehicle operation. Warning lights, such as the check engine light or transmission warning light, might illuminate on the dashboard, indicating that the vehicle's onboard diagnostic system has detected an issue related to the output shaft speed sensor circuit. Additionally, there could be poor acceleration or overall performance declines, which can affect fuel efficiency. Identifying these symptoms early is crucial, as they may signal underlying electrical issues that need to be addressed promptly to prevent further complications. In the first step of troubleshooting the DTC P0723, begin by turning the ignition switch to the on position, labeled as II, keeping the engine off. This action powers the vehicle systems without starting the engine, allowing access to the necessary electronic components. Next, using the Honda Diagnostic System, HDS, clear any existing diagnostic trouble codes. Clearing DTCs is important for establishing a baseline for monitoring current vehicle performance. Ensure that the vehicle is raised securely on a lift, allowing the technician to safely perform checks on the wheel assembly while maintaining stability. This setup is necessary for subsequent tests, ensuring that the front wheels can rotate freely without obstruction. By completing these initial steps, you will prepare for the next phase of diagnostics that involves speed measurement comparison. Step 2 of the troubleshooting process involves checking the voltage in the VCC1 line, which supplies power to the output shaft speed sensor. Begin by ensuring the ignition switch is in the lock position before disconnecting the output shaft speed sensor 3P connector. Reactivating the ignition switch to the on position 2 allows you to measure the voltage between specific test points. These points include output shaft speed sensor connector pin number 3, often PNK colored, and body ground. Using a multimeter, confirm that the voltage reads approximately 5 volts. If the measurement aligns with this specification, the VCC1 line is functioning properly, allowing you to advance to the next troubleshooting step. However, if the voltage is absent, it suggests a problem within the VCC1 wiring that needs repair before proceeding. In Step 3, the focus shifts to assessing the NC line associated with the output shaft speed sensor. Again, ensure that the ignition is set to on, III, while the output shaft speed sensor 3P connector remains disconnected. Utilizing the multimeter, measure the voltage between output shaft speed sensor connector pin number 2, commonly light green, and the body ground. A reading of approximately 5 volts indicates that the electrical NC line is operational and that you can progress to Step 4 in the troubleshooting sequence. If the voltage is not detected, you must move to Step 5, as this indicates further issues with the NC line that require investigation for faults such as opens or shorts in the wiring. This step is crucial for isolating the potential source of the electrical issue, contributing to the DTC P0723. Step 4 requires a continuity check on the SG1 line from the output shaft speed sensor. Start by turning the ignition to the lock position and maintain the output shaft speed sensor connector in a disconnected state. Next, utilize a multimeter to assess continuity between output shaft speed sensor connector pin number 1, typically gray, and body ground. Should the multimeter indicate continuity, the SG1 wire is functioning correctly, leading to a suggestion that the issue may reside with the output shaft speed sensor itself, requiring replacement. Conversely, if continuity checks yield no readings, it indicates an open circuit in the wiring between the sensor and the powertrain control module, PCM, necessitating immediate repairs to ensure sufficient signal transmission. This step is vital for effectively addressing the sensor's operational efficiency. In Step 5, you will check for a short in the NC line between the output shaft speed sensor and the PCM. Begin by turning the ignition to lock and utilizing the HDS to jump the SCS line, ensuring that electrical connections are properly isolated. Disconnect the PCM connector B, which is a 49-pin connector, to facilitate accurate measurements. With the multimeter, examine continuity between the output shaft speed sensor connector pin number 2, light green, and the body ground. If continuity is evident, this signals a short to ground in the NC wire that must be addressed with repairs. However, if no continuity is detected, it indicates that the wire might be open, requiring attention to restore the necessary electrical connections. This thorough diagnostic step ultimately aids in pinpointing where the fault lies within the electrical circuit. Repair verification serves as the concluding phase following steps taken to address the DTC P0723 issue. Initially, make sure that all electrical connectors are properly and securely reconnected to restore the functionality of the transmission system. Once the connections are secured, move to turn the ignition switch to the on position to allow the necessary vehicle systems to boot up. Following this, utilize the Honda Diagnostic System HDS to clear any remaining diagnostic trouble codes, resetting the system and preparing it for a fresh evaluation of vehicle performance. It is crucial to restart the engine and disable the Vehicle Stability Assist (VSA) system by pressing the VSA off button. Wind this up by running the vehicle with the shift lever in drive, keeping speeds above 12 miles per hour, 20 kilometers per hour, and monitoring the input and output shaft speeds through the HDS. If they align, the troubleshooting is deemed successful and complete. To prevent the recurrence of a DTC P0723 and maintain optimal transmission performance, regular preventive maintenance is essential. Conducting consistent electrical inspections can help identify potential issues such as frayed wires or corrosion early on, before they escalate into more significant problems. It is advisable to routinely check the connections associated with the output shaft speed sensor to ensure that they are secure and free from dirt and moisture, which can compromise performance. Additionally, addressing any signs of corrosion on terminals promptly will help maintain uninterrupted electrical signals. These proactive measures not only enhance vehicle reliability, but also contribute to the longevity of the transmission system, reducing the likelihood of unexpected repairs and downtime, which can lead to inconvenience. In conclusion, the troubleshooting process for DTC P0723 surrounding the output shaft speed sensor underscores the importance of addressing electrical issues within the system promptly. The output shaft speed sensor is integral for ensuring proper transmission performance. Hence, identifying and remedying faulty circuits is vital. Regular performance monitoring, paired with diligent preventive maintenance practices, can significantly reduce the probability of recurrent issues. Ensuring the integrity and cleanliness of all connectors and terminals ensures reliable signals to and from the PCM, promoting long-term vehicle health. This entire diagnostic process aids in maintaining the high performance of Honda CRV models from 2011 to 2016, ultimately ensuring a satisfying ownership experience. Please like and subscribe to the channel. See you next time.